In this video, we're going to talk about trig ratio. Okay, so when we're talking about trig ratios, we're most likely referring to relationship between angles and sides of a right angle triangle. Okay, so a right angle triangle is a triangle that one of its angles is 90 degrees. Okay, so most times you see a symbol of this form. Okay, so we have a triangle on our screen. Is triangle ABC, and then we have an angle theta. Okay, so trig ratios happen when we try to relate our angle and two sides of our triangle. Okay, so from our angle theta, this is the opposite of angle theta, and then this is the hypotenuse. The longest side of the triangle is the hypotenuse. Okay, and most times it is opposite, or it is always opposite the 90-degree angle. So the other side is referred to as our adjacent. Okay, so when we try to relate these angles, we have terms like, if you try to relate opposite and hypotenuse, we have sine theta will be equal to opposite over hypotenuse. Okay, so this is equal to, now opposite is AC, okay, divided by BC. Okay, so if you try to relate adjacent and our hypotenuse, you have cos theta. Okay, cos theta is adjacent over hypotenuse, which is equal to AB over BC. Okay, and then if you try to relate our opposite and adjacent, we have tan theta. Tan theta is equal to opposite over adjacent, which is equal to AC over BAB. Okay, so these three terms are referred to as trigonometry ratios. Okay, so to remember the relationships between how they relate in this triangle, there's a term called SOHCAHTOA. SOHCAHTOA. So SOHCAHTOA simply states the relationship between each of the trig ratios and the sides of the triangles. Okay, so sine is relating opposite and hypotenuse. Okay, so ka is cos, relating adjacent of hypotenuse. Then tan should be relating opposite and adjacent. So it is also arranged in the way they are related. So this simply means that sine theta equals to opposite. That's opposite should be on top, the numerator, and the hypotenuse. So the same logic applies for ka and toa. Okay, so now that we related all of this, let's take a few examples and understand how to use this to solve problems. So from this example, we have our angle. Say you have a ladder leaning against the wall. Okay, so this is the ground. It doesn't look much like it, but this is the ground. And then you have a height, a vertical distance the ladder covers. Okay, so you have your angle 45 degrees. Now if you're asked to find the height, what you are going to do is to find the relationship between the height. So the height is opposite our angle, so the height is opposite. Okay, and then this is a 90-degree angle, so this is a right angle triangle. Okay, so this is most likely the hypotenuse, the longest side, and then this is the adjacent. So we are going to find the trig identity that relates opposites and the adjacent of the triangle. Okay, so a trig identity that relates from SOHCAHTOA trig identity that relates opposite and adjacent is tan. Okay, so from here we know that tan theta equal to opposite over adjacent. Okay, so this means that our opposite value here is h, and then our adjacent value is 3.4. But don't forget our angle is 45 degrees, so 1045 equal to h over 3.4. Now if you cross multiply this fraction, this equation here, so you'd have h to be equal to 3.4 times tan 45. Now to find tans, you need to use a calculator. To find our trig identities, most times you need to use a calculator. Okay, so from calculator, tan 45 equals 1, so h equal to 3.4 times 1. So this is equal to 3.4 times 1 is 3.4 meters, because h from here 3.4 meters. Okay, because the other unit is in meters, so h is 3.4 meters. So let's take another example for you to understand better. Okay, so from this example, we have a ladder leaning against the wall again. Okay, so we are asked to find the length of the ladder. Then the other side, that's the height, the vertical distance of the ladder is 5. We have an angle of 43 degrees. So we know that this is a 90-degree angle. So this is the hypotenuse. Okay, then this is the opposite, because it's opposite the angle. And this is the adjacent. So next up, we find how to relate the opposite of the triangle to the hypotenuse of the triangle. Now going to our trig ratios, sine is the term that relates opposite to hypotenuse. Okay, so we have sine theta equal to opposite over hypotenuse. Okay, so this is simply saying sine, our theta is 45 from the question, 43 from the question, 43 degrees equal to opposite is 5 meters divided by hypotenuse. That's what we're looking for. So hypotenuse is L. So this implies that L, if you cross multiply, is equal to 5 divided by, so if you cross multiply and divide this side by sine 43. Okay, so this would mean that L equal to 5 sine 43 from calculator is sine 43 from calculator is 0.6820. It's 4 decimal places. Okay, so this L is equal to 5 divided by 0. So this is 7.33 to 2 decimal places. So that means the length of the ladder is 7.33 meters, so 2 decimal places. So that's how you solve questions in using trig ratios. Okay, thanks for watching the video. If you liked it, share, leave a like button and subscribe to the channel. Thanks for watching.